Welcome to our module on powers, and to give us a nice, clear, intuitive understanding on how they work, we're going to first take a brief look at multiplication. So say I had 5 times 3. What I'm essentially saying is I have 5 lots of 3, right? I have 3 plus 3 plus 3 plus 3 plus 3. I have 5 lots of 3. And I could reverse this as well. I could say 3 times 5, and that will give me 3 lots of 5. But now what if I had the expression 3 times 3 times 3 times 3. Well, in this case, what we're doing here is we don't have 5 lots of 3. What we're doing is that we're raising 3 to the power of 5. We have 1, 2, 3, 4, 5. We have 5 3's, and so we're raising 3 to the power of 5. So we have 3 to the power of 5. This larger number here would be considered our base. And this smaller number here, this smaller subscript, would be considered our power. And another term for our powers are our exponents or our index. I much prefer the term power because the terms get a bit cumbersome when we're talking about index in plural form, right? We have indices in plural. And again, I can have that with any number, right? I can have 7 times 7 times 7 times 7, and that would give us 1, 2, 3, 4. We're raising 7 to the power of 4. And in general, let's say we had our number a, we had some number a, and we raised it to the power m. That would give us a times a times, and we'll do a little ellipsis symbol there just to show that we're missing out some a's. And this could be any number of a's. We could have 1a or we could have 10 a's depending on the value of m. And so what we really have, well, we have m a's. So we're timesing m a's together, right? Alright, so I know this is probably looking a bit like spaghetti at the moment, so let me give you one small clear example. Let's say we chose a to be, let's say we just chose a to be 2, for example, and we chose m to be 3. Then we're going to have 2 times 2 times 2. See, note we have 3 2's here. Alright, so we're going to push this concept a little more further, and from this we're going to derive our first index law. Alright, so let's say we had this expression. Let's say we had 2 times 2 times 2 times 2. How many 2's do we have here? We have 1, 2, 3, 4, 5. We have 6 2's. 2 to the power of 6. Now I can decide to play around with these numbers a bit, and I could add some brackets in here. I'm not going to change the value in any way, shape or form. I'm just gonna change the form of the expression. So I'm going to put some brackets in here. And so what I'm essentially saying is 2 times 2 times 2, which is 2 to the 3, times 2 times 2 times 2, which is 2 to the 3, equals 2 to the 6. And notice that the powers of 2 here, they both add up. When we add them together, they get 6, right? And that goes for any way I choose to break up this expression. So if I had it like this, I could choose to break it up like this. I can put my brackets here, right? Put a bracket there. And that's going to equal 2 to the 6, because I haven't added or taken away any 2's here. I've just kept the same number of 2's. I've just changed the form a little bit, and that's it. So what we're essentially saying here is 2 times 2, which is 2 to the 2, times 2 times 2 times 2 times 2, which is 2 to the 4, and that again equals 2 to the 6. And then notice here 2 plus 4 equals 6. And I can split it up a different way. I can split it up like this. Let's say we had, say 2, 2. I could decide to split it up like this, right? I could put a bracket over that 2, these ones, and my answer would be 2 to the 6th. So what happens in this case? I have a 2 by itself, so I'm not multiplying this 2 by any other 2's. What happens in this case? Well, for any number, whether it's a whole number or whether it's an irrational number or a fraction, whatever type of number it is, if it doesn't have a power on top of it, its default is it's raised to the power of 1. The power of 1 is its default. So let's say we had the fraction 11 over 12, for example. That 11 over 12, as it stands now, its default is raised to the power of 1, right? And that still just gives us 11 over 12. So we would have here 2 to the power of 1 times 1, 2, 3, 4, 5. That's 2 to the power of 5 equals 2 to the power of 6. And then notice again here we have 1 plus 5 equaling 6. And in general, we could say that if I have a number a and I raise it to the mth power, right? I raise it to the power of m, and I times that by another a raised to the power of, let's say, n, I would have a to the power of m plus n, right? I have a to the power of m times a to the power of n, so I have m plus m, right? And so, don't worry, I'm going to give you an example. Let's say that the a in this case equaled 2, right? And the m was 3. And we multiplied that by, again, we multiplied that by a. A in this case, because we've chosen a to be 2 here, we have to be consistent here. So a again would equal 2, and let's say in this case n equaled 1, right? Then our total would be 2 to the power of 3 plus 1, which equals 2 to the power of 4. And we can actually test this, right? 2 to the power of 3 is 2 times 2 times 2, which is 8. And 2 to the power of 1 is just 2. So we have 8 times 2, and that's 16. So we've tested the left-hand side of the equation here. We have our left-hand side. And we have here on the right-hand side, we have 2 to the power of 4. So 2 to the power of 4 is 2 times 2 times 2 times 2. So 2 times 2 is 4, times 2 is 8, times 2 is 16. So we have 16 on this side as well. So we can see here that 2 to the power of 3 times 2 to the power of 1 equals 2 to the power of 3 plus 1 equals 2 to the power of 4. And we can take this example a little bit further. Let's have another. Let's say we had 2 to the power of 0 times 2 to the power of 3. So in the case here of 2 to the power of 0, any number raised to the power of 0 equals 1. So we can say that any number a raised to the power of 0 equals 1. So here we have 2 to the power of 0, which is, and we can do that first in index form. So we have 2 to the power of 0 plus 3 equals 2 to the power of 3. And we can test that. We know 2 to the power of 0 is 1 times 2 to the power of 3, which is 8. So that's 8. And on this side, we have 2 to the power of 3, which is 2 times 2 times 2. So we have 2 times 2 is 4, times 2 is 8. So we have 8 on both sides. And so we have our law here, a to the power of m times a to the power of n equals a to the power of m plus n. And that's only for if both of the bases are the same, right? If both of the bases are a, then a to the power of m times a to the power of n equals a to the power of m plus n. So notice it wouldn't work. Let's say we had 2 to the power of 1 times 3 to the power of 2. Notice here we can't add the powers here because the base of our number here, we have different bases. We have 2 and we have 3, so we can't do anything for an example like this. Alright, so I've given you some problems to work with here. The question is, write the following expressions in index form. You can go ahead and pause the video. Alright, so looking at our first question, we have 2 to the power of 3 times 2 to the power of 2. So notice here that both of our bases are the same. So we can just go ahead and add our powers here. So 2 to the power of 3 plus 2, we have 2 to the power of 5. Right, pretty simple. Alright, so what about our next one? We have 2 to the power of 3 times 3 to the power of 2. Well, notice here that our bases are different. We have 2 and we have 3, so there's nothing we can really do with that. We can't use our first index law, so that's in its simplest index form. So the answer to that would just be 2 to the power of 3 times 3 to the power of 2. Alright, so in our next question, we have 27 times 3 to the 4. Well, we know 27 is 3 times 9, and 9 is 3 times 3, so 27 must be 3 times 3 by 3, right? If we write that in a tree form, let's say we had 27, and we know 27 is 3 times 9, and we know 9 is 3 times 3, so we have 3 times 3 times 3, so 27 is 3 times 3 times 3, which is 3 to the 3. So we have here our 3 to the 3 multiplied by 3 to the 4. And so notice here our bases are the same. They're both 3. So we can just go ahead and add our powers. So we have 3 to the power of 3 plus 4, which is 3 to the power of 7. Alright, so looking at our next one, we have 5 to the power of 0. Now remember, any number raised to the power of 0 is always 1. Right? But so here we have 1 times 5, which is 5, times 2 to the 3. So we just have 5 times 2 to the 3. In fact, we can use our first index rule for this part of the expression here. 5 to the power of 0 plus 1, since both of our bases are the same, times 2 to the 3, and that will be 5 to the 1 times 2 to the 3, which is the same as 5 times 2 to the 3, right? So we've got the same answer here, and we got the same answer here as well. Alright, I hope you've enjoyed this module, and we'll be back again with dividing numbers in index form and raising numbers in index form. See you then.